Good afternoon, students. Welcome back to this third episode of your physics marathon class, and we are here to discuss some of the errors committed by you in the form of questions. So what these questions are all about. So let's understand the topics first, what these topics are. And myself, Puneet Kathuria, your physics faculty at Aakash, welcome you again. So let's go through the topics. So this episode or this session revolves around system of particles and rotational motion. And it will also be covering moving charges and magnetism, electromagnetic induction, dual nature of radiation in matter, and thermal properties of matter. So this current session involves around, or it involves all these topics, what all will be covering in today's this discussion. So let's start the discussion. Yes, the very first question says a shaft rotating at 3000 rpm is transmitting a power of 3.14 kilowatt. The magnitude of the driving torque is. Now let's start understanding this. So what is given to you is 3000 rpm. So basically this rpm stands for frequency. And this basically stands for 3000 rpm. So rpm is basically rounds per minute. So when you divide it by 60, you will end up with this as a frequency. Is transmitting a power of. Second is power is given to you as 3.14 kilo. Kilo means 10 to the power 3 watt. The magnitude of the driving torque. So first we need to remember this formula, because this is something which is given to you as instantaneous concept, because this frequency is given to you at any instant of time. So here we'll be discussing or we'll be talking about instantaneous power, and instantaneous power is given to you as tau dot omega, that is angular speed. And what is given to you as frequency? So it means we need to find out omega first, and this is 2 pi times nu. So this is how we'll get omega, and this is rpm means rounds per minute, so we'll convert it to rounds per second. So that will give you the value of omega, and using this 2 pi frequency rounds per second will give you the value of omega. So let's put the value, because we have to find out driving torque. So this is what you are supposed to find it out, torque. So this torque is the variable that we have to find it out. And what is omega? Omega is 2 pi into frequency, and frequency is 3000 rounds per minute. So that we have already converted to this one. Now when you do the calculation, this pi goes with this 3.14, so that nullifies. This goes with this, and this goes with this, and this goes with this. So that gives you the value of tau as numerically as 10, and the unit wise we can write it down as Newton into meter. So this is how torque, we got the expression for the torque, we got the numerical value of torque as 10 Newton into meter, and this is the correct option we have. So finally we have obtained the answer for this. So my suggestion to you again, which I have been repeating you, advising you, requesting you in my previous sessions also, you please make a list of all the formulas, as a formula chart. And if you know the formula, you can solve the numerical in no time. So this is my suggestion to you for all the NEET aspirants who all are preparing for NEET. Otherwise also this question is quite easy. So, but if you don't remember the formula, then the same easy numerical will appear to be a challenging one. So, any doubt? So, shall we move, or if you have anything? And I'll give you one trick also to remember the formula. Do we remember the concept translational or translatory motion? And instantaneous power. I am writing instantaneous power as P instantaneous, and this is F dot V. Got it? So, same way, if you need to remember the same analogous formula for rotational motion, so for the same instantaneous power, what you have to do is, you just replace this force with its parallel analogous expression as torque, tau. Tau is again a vector quantity, dot V. So, we'll replace V with omega. So, this is the formula, and if you know this formula, that is for translatory motion, it's very easy for you to remember the formula for the rotational motion also. So, this is the easiest way to remember all the formula or the analogous, all the terms which are parallelly existing in rotational motion, if you know all the formulas for the translatory motion. So, I think this has added the way how you can remember the formula for the rotational motion. So, shall we move? Now, this is something really important, really interesting, and this kind of question has been repeated number of times in your earlier or previous year exams. So, please pay attention. A black body has a wavelength lambda m corresponding to maximum intensity at 1500 Kelvin. Its corresponding wavelength at 2500 Kelvin will be. So, first of all, I would like to introduce this concept revolves around Wien's displacement law. And you know what this Wien's displacement law deals with? So, first you try to understand a graph. So, this graph is between lambda and E lambda. This is spectral emissive power. And you know, this is how we defined it. This is defined as rate at which your surface, and here we are talking about black body, which is a perfect emitter. So, black body, how we define a black body? Black body is something which has a tendency to absorb all the incident radiations on it. So, it means if it has acquired or absorbed all the radiations, when it comes to emission by virtue of its temperature, so it has a tendency to emit you varieties of frequencies or wavelengths. So, it means the rate at which surface emits radiation of given wavelength in all possible directions. So, this is spectral emissive power, and when you plot this relation of E lambda with lambda, so I define these like these. So this is at temperature 1 and this may be at temperature 2. And you know this is lambda at which it has given you the maximum emissive power. And when you increase the temperature, here the important point is your this T2 is greater than T1. So look at this T1 curve and this corresponds to lambda m. And when you increase, when you plot the same for the body that is at a different temperature, T2, and you know T2 is greater than T1, what you have observed? Don't you think its lambda is displaced towards decreasing side? And because of this reason only, because you have plotted the same graph at different temperature, and with the increase in temperature, what you have noted or observed is, this is important, your lambda corresponds to this maximum emissive power. It has shifted towards this side, lower side. So because of this displacement in lambda m, this is known as Wien's displacement law. This is important. And the second important point is this lambda m is definitely inversely proportional to temperature. And this lambda m into T is constant. This constant is B. We call it as a Wien's constant also. So lambda m into T remains constant. And this value of this constant, if I give it to you, this is 2.9 into 10 raised to the power minus 3. And if I give you the units, that would be lambda m means wavelength, that is in meter, and temperature is in Kelvin. And this is the value of Wien's constant, B. So it means this is lambda m into T, that product remains constant. So if you have understood this concept completely, then this question is quite easy and interesting now, because we have to remember this part only. That means this lambda m into T is constant. So let's apply this. So lambda m into T is constant. So it means if you increase the temperature, lambda decreases but product remains same. So lambda 1 T1 is equal to lambda 2 T2. And in the given question, lambda m, it corresponds to maximum intensity at 1500 Kelvin, and we have to find out lambda m at 2500 Kelvin. So this is 1500 Kelvin. This lambda we need to find it out. This is the one we are looking for, and temperature 2 is given to you as 2500 Kelvin. So I think this is one of the easiest numerical, but simultaneously this is one of the important numericals we have, because this kind of numerical, or rather this variety of numerical based on Wien's displacement law, it has been asked number of times in your previous exams of NEET. So now we can easily find out the value of lambda. So lambda m, these two zeros go with this, and this is 15 by 25, and this is 3 by 5. So lambda is, the new lambda is 3 by 5 lambda m, and this is the given answer we are looking for. So yes, 3 by 5 lambda m is the answer for this numerical. Any doubt? Any doubt? So I think if you have understood this concept also, so shall we move? Shall we? Okay. Now, The next question is again important from a different concept, and this is one of the important articles. We have it even for the NEET, and this was again one of the important contender for your board exam also, and you are already done with your board paper. So let's attempt this question for your NEET. The current sensitivity of a moving coil galvanometer. So this is moving coil galvanometer, and then we have current sensitivity. So what do you mean by current sensitivity? And this is current per unit deflection. And again, very easy, we can understand this concept again well in detail also, but as your question revolves around this one, so I would rather again suggest you, why don't you deal it directly with the formula. So current sensitivity is given by this formula, and what is this is NBA. So N is number of turns, B is your magnetic field, A is your area of cross section, and that is area of your, basically it's area of coil, and K is your spring constant or torsional constant. So once you have all the variables involved in your concept of current sensitivity, then it can be increased. So we have to increase it. So how you can increase it? So it can be increased by increasing the number of turns, because that is in direct proportion. It can be increased by this one, increase in magnetic field. It can be increased by increasing this one. And if you increase K, look at this, current sensitivity will decrease, but we have to increase it by decreasing K. So it means if you decrease K, current sensitivity will increase. So the same question can be asked in a variety of ways. So if you know the mathematical formula, then you can answer this pretty well, very easy. So you have to just make out the relation, how this increase in one factor will increase. Yes, current sensitivity is, yes, Dashrath Sharma, yes, this is right. Current sensitivity is what? Current deflection per unit current. So this is deflection per unit current, we can define it. Yes, Dashrath, quite impressive. You are, I'm quite good. So current per unit, deflection per unit current, that is called current sensitivity. So this current sensitivity formula remains the same. So this is how we have to go for this. If you have understood it, shall we? Fine. So the question is by decreasing torsional constant of spring. That is the option. So it can be increased by decreasing K. So shall we move? Yes. So next question is also quite interesting. So just pay attention. An EMF of 8 volt is induced across the ends of an inductor. When the current through it changes from 5 ampere to 1 ampere uniformly in 2 milliseconds, the value of self-inductance is. So first, this is induced EMF, and induced EMF is defined as rate of change of magnetic flux with respect to time. So this is d phi by dt. And to be very precise, we need to put a negative sign. This negative sign is because of Lenz's rule. So that clearly says the direction of induced EMF is such that it will oppose the change of flux. So but now we are dealing with magnitude of induced EMF. So this is, so we'll drop the negative sign because this negative sign is already defined in Lenz's law. So but when you define the magnitude, so it has no significance for the magnitude part. What is the flux associated with your this? So this is associated with your inductor, and this is Li. So this is L di by dt is the magnitude of induced EMF. So this is the required formula what we are looking for. I hope we have understood the formula now. So now let's play the game with putting the values. An EMF of 8 volt. So this is 8 volts. Current changes from 5 ampere to 1 ampere. So what is the change in, what is the magnitude of change in current? So that means 5 to 1 ampere. So this is decreasing 1. So change wise it would be 4. And how much time you are taking for that change? 2 milliseconds. 2 into 10 to the power minus 3 seconds. You got it or not? So now just using this, so this goes with this and this goes with this 4, and when you take this on the other side, this is the value and this stands for milli, and the unit for this is Henry. So shall I say 10 raised to power minus 3 stands for milli, and this is 4 millihenry is the numerical value for the L. Sir, if you set paper and then set it little tougher, sir, please. Nothing is difficult here. This is my feedback, sir. Right, sir, Tanmay, I have taken your feedback, but these all are already conducted exams. So definitely your feedback is taken well, and we'll keep it. Anything else? So Tanmay will definitely take care of it and wait for the next exams to happen. So basically this exam has already been conducted on 23rd. So we can't do anything for this one, but for the next exams we'll definitely go with your suggestion. Anything else? So shall we move on? Shall we? Anything else? It's a nice suggestion and it's good. You people are doing it, you people are learning it, and you people are taking advantage of this. So I've got a feedback from Tanmay, and that is well taken, and it will be passed on to the concerned department to take care of this. So till then I think we should continue to discuss. Yes, the next question is again quite interesting. Now this is basically one of the standard formats we have, and this is for regarding your assertion and reason. In photoelectric effect, increase in intensity of light increases the photocurrent. This is one assertion. So let's photo electrons, I am introducing first word. Then we have photoelectric current. Then we have another term called intensity of light. Now, what do you mean by intensity of light? Light being a wave, intensity is basically energy per unit area per unit time. But particularly here we are talking about not the wave nature, but here we are talking about the particle nature of light, and that is to do with the photons, the particle nature of light. So the particle character of light is photon. So what do you mean by intensity? Intensity means number of photons hitting or striking per unit area per unit time. So this is to do with this, the number, and your photoelectric effect that deals with the collision of these photons with the electrons. So this is one-to-one collision. This is, all these collisions are elastic. So these are basically one-to-one collisions. So it means if you have dropped one photon on the surface, it will help you to emit one electron, probably one-to-one collision. That is the basic assumption. And the electron so emitted, that is called photoelectron. You got the concept? So one thing is photon, that is particle nature. How many photons are striking per unit area, that will define the number of photoelectrons emitted, and that will define ultimately the photoelectric current. So if you have more photons, more photoelectrons, more photoelectric current. So how this photoelectric current, so we have photoelectric current with respect to intensity, and that intensity is to do with the number of photons. So as intensity keeps on increasing, photoelectric current keeps on increasing. So this is the correct statement, correct assertion. Yes, coming back to the same question. In photoelectric effect, increase in intensity of light definitely increases the photoelectric current. This is what we have just discussed. So this is true statement. So this assertion is true. I hope we have understood. Assertion is true. Then at stopping potential, photoelectric or photocurrent is 0. Now let's understand this concept. So as per your Einstein's photoelectric equation, so this is the incident energy, and definitely the emission photoelectron will be emitted only when this incident energy is greater than threshold energy, or it has to overcome the work function, and the rest of the energy will be your kinetic energy. You got it or not? So with this extra energy, the photoelectrons emitted, they are actually in motion within that material, and that is the kinetic energy they possess. And if you need to stop this emitted electron, so we need to apply potential in the reverse direction, what you call it as stopping potential. So the word itself says that stops. So what do you mean by stopping potential? The definition of stopping potential says the potential applied in the direction opposite to the motion of the photoelectrons, and that will bring the photoelectrons to rest. So that will bring them to rest. So this is what? This is called stopping potential. So it means if photoelectrons so emitted because of the incident photon, so if you apply stopping potential, that means potential in the opposite direction, that will stop the moving electron. It means that will stop, means that will bring the photoelectric current to 0. So at stopping potential, photoelectric current is 0. This is also correct statement. So reason is also correct. But now think of it. This R is explaining the assertion, is giving the answer to your assertion? No. These are two correct statements, but reason is not the correct explanation. So both assertion and reason are true. And this is what we have just discussed. Both statements are true, but reason is not the correct explanation of the assertion. Reason is not the correct explanation of the assertion. So what is the best option? We'll pick for this. It means assertion is true, reason is also true, but reason is not the correct explanation for the assertion part. And that is why we have picked up option 2 as the correct answer for this. So this assertion reason format is again very important format for your NEET. And what you have to do is you have to understand the assertion statement independently. You have to understand the reason statement independently, completely. You understand the physics. Then you raise your assertion as a question to yourself and read the answer for the assertion for the reason part again. And what you as per your understanding of subject, as per your physics concepts, if you are confident that your reason is answering your assertion, reason is answering your assertion, then you have to give this statement as that means assertion and reason both are true, but reason is not the correct explanation of the assertion. I hope we have understood this part also very well. Any doubt? Good. So I think we should move on. Now, the next question is again interesting one from your system of particles, from your rotational motion concept. This is topic from your +1 standard, 11th class. Moment of inertia of a uniform rod of length L and mass m about an axis passing through point A and perpendicular to the length of the rod is. So first we have moment of inertia, which I am writing it as I. Moment of inertia, let's understand some of the physics. What do you mean by moment of inertia? So if you write it down mathematically, this is I is equal to mk square, where m is mass of the system and your k is basically radius of gyration. And this radius of gyration is also known as root mean square distance. So this is basically a scalar physical quantity. And moment of inertia in rotational motion, what it does for you, what is the significance of this? It plays the same role what your mass does it in translatory motion. So in translatory motion, mass is to do with this concept of inertia, inability of a body to change its state of its own until unless an external force is applied. So that means mass is to do with the inertia. So moment of inertia is to do with the inability of an object or a system or a body about its axis of rotation until and unless you apply a rotational force, or that is torque, to change its state of rest, state of motion, or state of rotation about the fixed axis of rotation. So that means I plays the same role what mass does it in translatory motion, I does it for the rotational motion. You got the concept? So this is basically the first thing we need to understand. Moment of inertia is very, very important, and this is analogous to mass. What mass is there in translatory motion, I or moment of inertia is there in rotational motion, and this is a scalar quantity. Now let's define the moment of inertia of this rod. So we have a rod, its mass is m, length is L. So this is the one. Got it? Now we have to define the moment of inertia of this rod. So where is the axis? Where is the axis? So let's define this as your axis, which is passing through its center of mass. This is rod is assumed to be a uniform rod. This is assumed to be a uniform rod. Do we understand? Now I am asking about its moment of inertia about an axis, and that axis is passing through its center of mass, that is perpendicular to its length. So this is my axis, passing through its center, passing through its center of mass, passing through the center of the rod and perpendicular to the rod. You got it? So let's suppose if I consider this one as a uniform rod, so I'm asking about moment of inertia about this axis. So if you allow this to rotate, what is the moment of inertia of this rod about this axis is? You got it? So this is my question. Because this rod is defined or assumed to be as a uniform rod, so its linear mass density, that is mass per unit length, this is uniform, or this is assumed to be a constant one. This is also important. Now to define this, let's understand, because we have taken the length as L, so the coordinate for this part is plus L by 2 and coordinate for the other end is minus L by 2. So these are the coordinates. Let's consider a small element, and mass of this small element dm is written as mass m per unit length into the length of this element, I assume it as dx. This is the one. You got it? And let's suppose this small element is assumed to be at distance x. This is perpendicular distance, that is radius of gyration for this element dx. So what is the small moment of inertia for this part? And this is dm into perpendicular distance, that is x square, because we have just defined it as mk square, and for the total one we need to integrate it. This is all. So what is dm? M by L and into dx. So this is primarily x square into dx. Then we need to define the limits for the integration, and limits for the integration are basically the coordinates starting from minus L by 2 to plus L by 2, and moment of inertia for this is what? M by L, that is there. So this is x cube by 3, and when you put the limits, so this would be L cube by 3, L cube by 2, and this is 2 cube means becomes 8, and this is minus L cube by 8. And when you integrate this, so this is basically the integration of this part will be x cube by 3. So there will be one more factor of 3 over here, and this is, and when you solve it, it would be ml square by 12. So this is the moment of inertia of this rod, uniform rod, about an axis passing through its center, and that center is center of mass perpendicular to this rod. So this is the one. This is the one. But what is the question? We have to find out moment of inertia of a uniform rod of length L, mass m, about an axis passing through point A and perpendicular to the length of the rod. So if I consider this one as yours, this one as your first axis, so I am asking moment of inertia about this one. I call it as I dash. So this is the question we have. You got it? Now, this we have already obtained moment of inertia through its center, its center about an axis, that is through center perpendicular to the length, and this is center of mass also. Now, to find out moment of inertia about this, which is like a parallel axis, so we'll go by parallel axis theorem. And that clearly says moment of inertia I dash, which is parallel to an axis that is passing through its center of mass, plus m h square, where h is this distance, which is this perpendicular distance between these two parallel axes, and this is L by 2 only. So this part we have already obtained as ml square by 12, and this is m, mass of the rod, h is L by 2, square becomes ml square by 4, and when you take the LCM and solve it, it becomes ml square by 3. So this is the required expression we have, ml square by 3. So here we have understood the moment of inertia about an axis passing through its center of mass perpendicular to the rod. So that was ml square by 12. And then moment of inertia about an axis which is passing through one of the ends of the rod. So if you just look at this, so this is the axis which is passing through its center, but we are here to find out the moment of inertia about an axis which is passing through this end of the rod, which is normal to the rod. So that we got it using parallel axis theorem, and the answer is ml square by 3. So I hope we all have understood this part also. Shall I put you one more based on the same? Let's suppose if I ask you moment of inertia about this axis, which is at a distance L by let's say 4 from one of the ends, and you have to find out moment of inertia of the same rod, same uniform rod, about an axis which is passing through this point, which is at a distance L by 4 from one of the ends, and that is again normal to the rod. You got the question? Initially you had it from point A, that is from the one of the ends of the rod and normal to the rod, but this time we are asking for this which is passing through a point which is at L by 4 from one of the ends of the rod and again perpendicular to it. So we'll use the same concept, parallel axis theorem. So this I is basically again I of center of mass plus mh square. I center of mass you have to remember, and this is ml square by 12 plus m. What is h? Can you see this h? This time this h is again L by 4, because this was total L by 2 and this is L by 4. So the other is also, and when you put the values as ml square by 16, just solve this and that is the required expression what we are actually looking for. So I hope I have given you one parallel question based on this, on the same concept, and you can be asked n varieties of questions based on this. So what is important is, I am again suggesting a great piece of advice to all of you. One thing is, you just remember all the moment of inertias listed for all the symmetrical geometries, whatever it is. All these 5-7 formulas are listed in every book, so I would rather suggest you just remember all these formulas. Second, just note down the parallel axis and the perpendicular axis theorem and just attempt, because most of the questions you can solve it by just remembering the formula and applying your simple concept of what? Simple concept of parallel axis or maybe perpendicular axis theorem based on the numerical. And that is how we can solve any of the numericals. Important point, this is a scalar physical quantity. So it means scalar physical quantity. So if you have more than one particle for the distribution, then moment of inertia for the system is contributed by all the individual masses, and you have to just simply add it mathematically, algebraically, because this is a scalar physical quantity. Shall we? And Ronak has given a very nice answer, 7/48. Thank you, Ronak. And I suggest other ones also to verify this answer, whether Ronak has given the correct answer or not. So this is 7/48 ml square. So I think we should move on. Now, a charged particle Q is moving with uniform speed V, enters in a region of uniform magnetic field B and normal to the field. The path traced by the particle is. So you have a charged particle moving with speed V, enters into uniform magnetic field B. You know it experiences a magnetic force, and that is given to you as QVB sine theta, which you can write it down in vector form as QV cross B. So this is the magnetic force experienced by charged particle whenever it enters in uniform magnetic field B, where theta is what? Theta is the angle between velocity vector and magnetic field vector. So theta is angle between V and B. And here it says it enters in a region of uniform magnetic field B normal to the field. Normal to the field means theta is given to you as what? 90 degree. And we know sine 90 is 1. So this force would definitely be the maximum force, and that we can write it down as QVB. Got it? So this is the numerical expression for your magnetic force experienced or force experienced by charged particle whenever it enters a uniform magnetic field region B. This is the one. Now, what is the direction and what should be the path? We know whenever you have this maximum magnetic force, so this will provide you centripetal force. And when you say it provides you centripetal force, mv square by r, where m is mass of the charged particle and r is called its radius. Sometimes in general this r can also be understood as its trajectory. Got it? Because we have already stated it, we have already defined its path. Can you guess the path? Now do we have a straight line path? No. No. Do we have a helical path? For this situation, it is for theta equal to 90, there is no helical path. but definitely we can have helical path also. I'll explain it to you in just a minute. Parabolic, no. Definitely circular path, because this is giving you a centripetal force. And trajectory, we can easily write down its trajectory r as mv by qb also. So this is the radius, or this is the trajectory followed by your charge particle. Any doubt? Any doubt you have? Sure? Now, I have just hinted you when it will have a helical path. So let's suppose your magnetic field is somewhere around this axis, along this axis, and your charge particle, it enters with some velocity v, and this is your general angle theta. Now if you split this, so this is v cos theta, and this is what? V sin theta. You got it? Now this is, I assume this one as branch 1 and this vertical as branch 2. If I ask you force in branch 1, so force is Q, V is V cos theta, B sin theta. Now just pay attention. We have just understood this theta is angle between velocity vector and magnetic field vector. So what is the angle between velocity v cos theta and b? This is 0. So sin 0 is 0. So that gives you 0. It means v cos theta will not, because of this v cos theta, charge particle will not experience any force. What about v sin theta? So charge is there, v is there as v sin theta, b is there, and what is the angle between v sin theta and b? That is definitely 90 degree. So this force would still be q v b sin theta, and this is the maximum force, and we have just understood maximum force means the circular path. So it means what will happen to your charge particle? This will provide you the centripetal force. But v cos theta, though because of v cos theta, charge has not experienced any force, but will continue to follow its v cos theta along b. So what you will observe? It will continue to follow and it will continue to move along this. This is how it follows your helical path. So your question was, can we have helical path if a charge particle enters into uniform magnetic field? Answer is yes. When theta was assumed to be 90 degree, then the trajectory or path would definitely be a circular one. But for theta, any generalized theta that is not 90 degree, maybe any angle between 0 to 90, then charge particle may have a helical path also. So in that situation, helical may be one of the options, but only when theta is not 90 degree. If theta is 0, definitely there will be no force, because sin 0 is 0. So in that situation, magnetic force would also be 0. So this is for this part. The unit of magnetic field, B, I think we can write it down as Tesla. So do we have Tesla? No. So then the other unit is Weber per meter square. That is another unit. And how we can have it? Flux is B dot A. So this we can have it from Weber per meter square as the unit for the B. So do we have Weber per meter square? Yes, this is the correct option for the units. It's me. Sir, please tell admin make shots of these all sessions, all chapters. Sir, congratulations. I mean like, I'm not sure who is, it's me. So until unless I'm sure, and you can, confirm it from the other areas, I'm not well sure. Definitely, if you connect with the office, they will let you know. So I think we should move on. Energy required to establish a current of 2 ampere in a coil of self-inductance 400 millihenry. So this is the direct formula. Again, if you know the formula, what is the formula for the energy stored in an inductor? This is half Li square. So I think if you have the formula, you just need to put the values. What is the value of L? 400 milli, 10 to the power minus 3 Henry into, what is the current? Current is 2 and 2 square becomes 4. So this 2 becomes 8 and this is minus 3. So this is 0.8 energy wise. This is joule. Yes. So this is 8. So this is, so that is how we got the option as 1. Any doubt? Do we have? Yes. Self-inductance of primary and secondary coil of a perfectly coupled coils, 4 millihenry, 9 millihenry respectively, the coefficient of mutual inductance. So this is to do with the mutual inductance, and if I give you M is basically the coefficient of mutual inductance. So you have 2 coils. This is coil 1, this is coil 2, and these two have some mutual inductance also, and this is how these 2 coils are related to each other. This K is basically the coupling constant. And you know, when you say these are perfectly coupled, so for perfectly coupled, the value of K is 1. So this is for perfectly coupled coils. So when you put K as 1, what you end up with? M is equal to L1, L2 under the root. What is L1? 4 millihenry, 9 millihenry. Millihenry will come out, and this becomes 36. So this is 6 millihenry. So that is straightforward question. So this is all for today's session, and again I say thank you to all of you for attending this session. Myself Puneet Kathuria, your Aakash faculty at Aakash. So we are very happy that today you participated with great energy, and you please continue with the same momentum, same enthu, and I wish you good luck for your NEET 2025. Thank you kids.